Welcome to the migration of regular WAN to SD-WAN session here at the Partner VT. My name is Bill Wazalewski. I'm a Enterprise Network TSA in the channel. And we have Prashant here to walk us through a pretty good presentation on migration, things to consider, and the overall solution.
All right. So, thank you, Bill. Good morning, everyone, and welcome to Partner VT session. And my name is Prashant Tripathi, and I'm Technical Marketing Engineer for SD-WAN. I mainly work for APJC and EMEA, and this is the first time I'm doing here, so thanks for joining. Today, we are going to talk about the migration from SD-WAN to, from traditional to SD-WAN, and what do we do to migrate from, traditional to SD, what sort of things we have to take care about. All those aspects we're going to discuss here. So there are a couple of things we're going to cover in this. We're going to talk about the planning. We're going to talk about how we're going to migrate DC sites, how we're going to migrate hub sites, as well as a branch migration, what we should do when we migrate from branches from traditional to SD-WAN. And then we summarize things. All right? So how many of you are familiar with these components? Yep. Nice. So I'm sure everybody in this room should be knowing about Cisco SD-WAN and the components what we are using as of today, considering control plane, data plane, and the pointers, what we do. So I'm not going to go into deep dive to each and every component, but I'm going to talk about as a high level what they do. And please feel free to ask the questions if you have any, so that we can make it a very interactive session. Thank you. So as we all know, in Cisco SD-WAN, we have decoupled the control and data plane. So if we look at absolute bottom, we have a data plane, which can be a virtual, which can be physical, which can be a VH, which can be ISR, ASR. Anything which is running SD-WAN is what we have a data plane. On top of this, we are going to get a quality of security, which we are launching in November, as well as a multi-cloud stuff and app queuing sort of result, because whenever you have a data plane, you're going to run a lot of applications, and you need to have visibility for those applications. And if you, as I asked, you are very familiar with the slide. So and the components. So if you see in this, we are missing the vBond. So vBond is orchestrator, so we just did not keep it here. But yeah, so as you have already gone through the component-wise, so you must be understanding what vBond does, what sort of orchestration, what sort of role it plays in the SD-WAN components. So if you look at the controllers is the guy who takes care of the routing updates and OMP stuff, and he's the decider for who does what and sort of policies we're gonna do on the controllers. And then there's the NMS, which is vManage, and from which we can monitor the stuff, defining configuration policies and all the things, just like NMS what it does. And then the last part is analytics. Analytics is additional sauce which grabs the information from the vManage NMS and does a predictive analytics for you. So any questions do we have so far on this? All right. So if you look at this part, so all of us have been gone through these use cases, and we have multiple questions from partners and the customers. How do we do for SLA-based routing? How do we do for service chaining? So all these aspects, we do that, some of them through the policies, some of them is the local policies. And there are many ways to achieve that. Could be simple, could be quite complex, but yes, as based on the scenario, we can go through that. So I'm not going to read those parts, but just for your information that this is what we do in this. If you have a use case, yes, we support those parts. So whenever we migrate from traditional to SD-WAN, so the only thing we have to spend time is the planning, right? doing configuration, doing policy push is a simple thing. It's like zero touch technically, right? The planning is where we have to spend time to understand what sort of template I'm going to do, and what sort of configuration a site needs, what sort of policies it requires to work on SD-WAN, considering the network requirement, right? So the planning where we're going to put the effort, and if you consider that we are replacing MPLS totally, so it's partially true, but not completely, right? So we're going to keep it there based on the need. On top of that, we give SD-WAN services, right? So the planning where we have to focus more than other stuff. Other stuff is quite plug and play now. So whenever we plan for migration, so the only thing that comes first is like whether we should go for the cloud controllers or on-prem controllers. So the first step, you have to plan the cloud controllers or on-prem controllers, and that's the first plan we have to build out before we roll out our data plane stuff, right? So if you look at cloud controllers, Cisco offers as a service where Cisco is going to take care about all the firewall, all security rules, and everything as a setup, and offer you as a service, right? So the first step, we are going to have built out the controllers, and then we go for whether we build out a data center hub and how to migrate that part. So we start with the control plane, and then we go to data plane. Data plane, we go for data center as the first site and do the migration for that, and then we move on to branches, right? Branches are spoke site. So that is how we plan. It's like planning a control plane and then data plane, and then go for hub and spoke models or the branches scenario. So as I discussed, so whenever we plan migration, the first thing we have to decide is like control plane, whether it's going to be on-prem or on cloud. Whenever it's going to be on-prem, the first thing we have to do is we have to have the firewall rules, we have to have security parameters taken care, so we have to have form those and fix those parts first. So it's like planning the controller deployment model, either cloud or on-prem. If it is on-prem, then we have to have all the security components and rules open to have communication from a data plane to control plane. And the next is like having your, planning your controller redundancy, like having a high available controllers, and then we have to plan the scale. So if you look at like every controllers have a limitation to support number of devices, right? So if you go from the left again, it's like planning your controllers, which mode you want to follow, on-prem or cloud, and then next goes is like what sort of firewall rules you have to open or you have to block, and then third is like redundancy for the controllers along with the scale, whether a controller can support 2,000 devices or not. Considering number of devices, you're going to plan those parts, right? So these are very important aspects of planning when you migrate from traditional to SD-WAN. And if those controllers are hosted in Cisco SD-WAN cloud, the Cisco is going to take care about those scales and those redundancy and which region they're going to keep your controllers as a active standby. So those things are already taken care of. So that's the advantage on that. So as I discussed, so we have two controller models. So one is like cloud, one is like on-prem. So if you have cloud controllers, which is taken care by Cisco, which means Cisco is going to take care about your firewall rules, about anything. It's technically additional services to you. It is not like you have to consider about going to the IT and getting those firewall rules fixed and then come and implement that, right? All the scalability, all the specs, and the things are taken care by Cisco if it is cloud-based, right? The on-prem is where you have to plan about considering and using your specs and know all the rules and as a components to open. So the recommended model, what we say is cloud-based controllers. That is where we promote as well, having controllers on cloud-based, and until it is very financial customer, let's say banking, who has some restrictions, not go for cloud, or some country has restrictions, not go for cloud. So we recommend you to go ahead with Cisco cloud controllers. Any questions? Yeah.
Are those controllers still only hosted in AWS? Or are you guys planning to move to a multi-cloud?
Yeah. So we have Azure as well. So we support AWS and Azure both. Yeah. And in terms of on-prem, you can go with KVM, you can go with OpenStack, you go with ESXi. Yeah. Thank you. So if you look at about the communication of the controllers and the data plane devices, right, how it happens if it is in Cisco cloud, because the devices comes from a customer premises or could be virtual and physical, there has to have a communication. So how they build out the communication, right? So your device will always point out to the orchestrator device, which is a vBond we call in today. And the vBond will always connect to you as a VH to the controllers on a public IP address, which is a netted IP address we do. So all these aspects are hidden for a customer perspective that Cisco takes care. These are only needed if you are troubleshooting something and you would like to understand what are the ports open, what are the IPs are done, but these are technically taken care. If it is a Cisco cloud hosted controller, it's like a service which is already taken care, and you don't need to worry about whether my public IP communication should happen, my netting should be done, that there are what sort of port I should open, right? So these are the pointers. And if you have a transport like MPLS, right, it's an optional you can enable control connection, or else if you really need that, let's say if you want to have redundancy for the MPLS as well, you can NAT that and have communicate via vBond and then go through the vSmart and vManage. So ultimately, if you go with the cloud hosted controllers, so these things are already covered. Those netting parts, the communication, you don't need to worry about what's happening in the background. The Cisco is taking care of all these parts as of today. So do we have any questions? I believe most of the customer, when they have MPLS and internet as well, they consider, okay, how I'm not able to build my control connection from the MPLS to the controller. Is it needed or not? If yes, how can I build? If not, then what should I do to avoid that part so that I can have my data connection up on that particular transport? So this is very commonly asked question, and just to let you guys know, yes, we have multiple options to do that, either netted way or from data center netted way, or you can disable control plane on the MPLS transport. So for any questions about controller communication? All right. So as I think most of you are aware about our control plane, so you must be aware about the certificate what we use as of today. So initially we used to use Symantec. Now Symantec is acquired by DigiCert, and we use the DigiCert certificate as a default in our cloud-based controllers, right? But you as an enterprise, if you're hosting controllers on-prem, you have rights to use your any CA which you would like to. So that facility is available, and you can just leverage having that sort of certificate. It's not like we are forcing to have the one certificate. It's up to you that if you trust something, and you can go ahead and use that if it is on-prem controller. All right. So there are So there are two ways you can deploy your on-prem controllers. One is having all the controllers on public IP address, right? Advertise that public IP address to your MPLS cloud and let MPLS transport communicate via that, right? Ultimately, what you point at your VH device is public IP address of your controller, which is a vBond. And the vBond lets every controller know, or every controller's IP know to you in order to have a communication. And if you would like to have, let's say there are a couple of companies, especially I have been couple of customers, their security team do not allow having public IP address on the controllers. So they would like to do NAT. So in that case, if you're doing NAT, you can go ahead with one-to-one NAT and then advertise that NATed IP to the MPLS cloud and let VH device talk to the vBond NATed IP address. As long as they're going to talk about NATed, they are going to talk to NATed IP address. That communication between the VH is going to go through on public IP address through the private transport. All right. And there are a couple of ways if you want to do communication on the private IP address. You have just one provider, and you have public private IP address, and you're NATing as well. So there are multiple ways you can make it happen. And it is doable, but the recommended way, what we say is like either have public IP address and advertise that public IP address to the MPLS cloud, or else NAT it and make sure the controllers, which means vSmart, vBond, and vManage, should talk to each other on a public IP address where it is public or when it is NATed, right? And have that public IP address or NATed IP address to advertise in the MPLS cloud in order to connect the device via MPLS transport to build out the control plane. Do we have any questions? Because generally you see these pointers when you have a financial customers where they're going to have those transports and they don't want to expose things out. So that is where we use these parts, and these are the solutions we have available at the moment. All right, so I think it's already covered this. So as I discussed, the firewall rule is very important here. So I'm not going to read these firewall rules. What we have is just a high level, or if you, to discuss here that we have summarized the rules, what you have to open from the VH to the controllers in your firewall when you're doing enterprise controller hosting, and that is how we should do. There are support pages, there are PPTs, or there are documentation we have listed where it is quite granular, and you can see and figure out what are the ports and why we need that. And if you look at, there are multiple range of the ports. There are many reasons about it, because the controllers like vSmart and vManage have multiple core. They build out the control connection on each core. That's one reason. And second is, like, let's say your firewall has something that is timing out, so you can port hop as well. So there are a couple of reasons to have these many ports in order to open from your firewall towards the controllers. As well as if you have any specific questions where you have some issues, we can take it offline after the session and discuss about what we should do or what we should not. So in order to have redundant controllers in your solution, you as a customer, we have two offerings. One is when you host the controllers in Cisco Cloud, what we do is we keep a set of controllers in a region and another set of controllers in another region. But if you look at here, we have a vBond in a region, and we have another vBond in another region, and vSmart. But if you look at the vManage, it is active standby. That's how it is designed as of today. As of today, it is cold standby. If one of the vManage goes down, you can have another running, just export the config DB of it, right? But if you have more, let's say you have around 2,000 plus VHs, right, which is, you need a scale, we have a cluster solution as well. So you can have a node of 3 as a cluster in vManage, and you can keep into one of the region and use as a cluster. And it can help you on high availability as well, plus scale parts. But when you're hosting controllers in your private cloud, which is on-prem, what you're going to do is you're going to have one set of controllers in one data center, another set of controllers in another data center. And from there onwards, you're going to take care about how many controllers do you need based on number of devices, based on the customer need, and you plan accordingly, right? The advantage, if you look at here, if your controllers are in AWS, what you do is like you keep running a snapshot. If something goes down, you can just restore the snapshot. Having things here in on-prem solution, you're going to have export database and do that. It's quite extra work for you sometime. Apart from that, this is fine. So do we have any question on this? That's also quite known. I mean, it's sort of quite known topic.
So how are backups handled when it's hosted in Cisco data centers? Does Cisco automatically back it up? Will they do restores? And can customers back it up and keep it on-prem if they want, their own backup copy?
All right, yeah. So for vSmart and vBond, they're going to be active. Only the vManage is where we have to take those backups. So we keep taking snapshot every day. We run 10 snapshots, and we keep it as a backup. So if in case your vManage goes down, we can take those snapshots and restore to your regional vManage, which is another region as a standby, and bring the services up. As well as it's always NMS. So whenever vManage has an issue or it goes down, it is not impacting your services. It is just NMS. But yes, the smart way, we have a snapshot. We just go ahead and put the snapshot, and it's up and running. So it's no interruption services.
Where are those snapshots? Are those snapshots stored in the same public cloud in the same region, or are they in a different region?
We have option to choose that. We generally do that. Let's say my vManage in region 1, I have an option to choose that snapshot to be another region, and then I can grab that. Because if I'm going to keep in the same region, if something goes down, everything's out.
Yep. So the customer can't actually export the config themselves and keep their own on-prem backups?
So you're talking about the on-prem case?
No. So they have a cloud hosted. They just want to export the config, keep their own backups.
Yeah, they can. So you have options. You can grab it as well with the command line, or you wanna export config DB. You can do that. Then you can take and restore somewhere. There is an option. But snapshot is quite smart way, it's everything is taken care of by a Cisco cloud upstream, and as a customer, you don't need to think about what should I take and what I should not. So that's one part. So we have mentioned a couple of times the scale numbers about the controllers, how many devices each controller handles. So these are the one, I think this is quite a slide where you guys have seen multiple times while working for a customer. So if you look at the limitation perspective, each vBond supports 1500, and that's what we have tested. There's no hard limit, but that's what we have come up, and with our testing, things are quite well. And each vSmart goes up to 5400 connections, and the vManage goes up to 2000 as each. As I mentioned, the vManage cluster is always when there's a scale issue, or if you want to scale your vEdges, and that is where you go for cluster. Otherwise, active standby is well enough. So these are the numbers. If you guys have any questions on the numbers, we can talk on that as well offline. So there are scenarios we have seen with the customers. Let's say they have 3 regions. One is in APJC, one is in EMEA, another is in the US, right? Every customer would like to connect their nearest vSmart controller, right? So we have terms, we call it Affinity, where we can say for each of your region, you can have your vBond FQDN, and you can point your devices to that FQDN, and you can prefer a controllers of your region. So what generally we do, we set all the controllers with a specific group, and we can tell you the VH devices, which group you should gonna connect, right? Similarly, if you look at here, US is in group 1, and EMEA is in group 2, and APJC, APAC is in group 3. What happens in this, like your edge device reach out to the vBond, right, and connect to the vBond as a regional, because you can have regional FQDN for your vBond. Let's say you have 3 vBond, you can have their IPs and define a new DNS and put your VH as a DNS for your vBond in a region. This generally comes with latency need, or there are some specific need in your case where you don't want to have a sort of latency in order to have control connections. And there are a couple of pointers comes into the picture where you have generally say regulations where you don't want to connect to outside your region any controllers or outside the country of any other controllers. So that's the one way, right? So reach out to your vBond with the help of FQDN, and then have a controller group ID defined where you can prefer which controller you want to connect first, and if that goes down, you have order of operation to connect second and third, right? So in this case, let's say if you are in APAC and you want to connect APAC as the first, but you want to have EMEA as the second, and then America as the third. You can define the sequences. Let's say first is this one. If that controller goes down, I want to go for another one. If that also goes down, the third is my America one, and that's how I can connect, and I can have high availability maintained along with my latency requirement, what I have today. But keep in mind, vManage is NMS. I can't have vManage every region. So I can have one of the location that we can decide whether it should go for AMER, EMEA, or APAC, and keep it one of the data center. All right. So any question do we have? Because generally we have those requirements from the customer where they want to connect to their regional data center or regional controllers in order to build the control plane, data plane, and they want to fall back to another region if that is out of reach, and that's how it is. So whenever we plan for migration, so how we consider things, right? The first thing, like your device goes and talk to PNP or zero-touch server, then we push out the control connections, and then our policies get pushed out, and based on the control policies, the data policy, we build out our connections with the device or another device and prefer link. So these are the 3 parts which are very important. Having a device connect to zero-touch server, a plug and play where you don't want to put any effort, it is plug and play. The next step is always getting the template and policies, and then scalability is the last part where we have to think about whether I should go for hub and spoke, considering my number of branches, the device which supports number of tunnels. Based on the scale, we go ahead and plan about it. So these are very important aspects of migration where we have to consider whenever we are designing a regional solution or the branches which are, I would say, on other routers if they are not capable of supporting those number of tunnels, considering number of branches. So I think, how many of you are familiar with ZTP or PNP in this room? Nice. We have good numbers. Thank you. So how about the PNP? Have we tried PNP? And the differences of PNP and ZTP, anybody is aware about? Technically, they function the same way, but what is the differences? So if you look at the VH boxes, they talk to ZTP server. If you look at CH boxes, which are ISR and ASR, they talk to plug-and-play server. VH boxes always go to ztp.viptela.com, they resolve ZTP of Viptela, and they get mapped to your overlay, and they talk and get the configuration posted. And Cisco boxes like ISR or ASR, they go and talk to device helper, and device helper has a controller profile set up, and they talk to the controllers or your overlay after which, right? So the best way, as you are aware about, whenever you buy something, any devices, any of the, I would say, solution in terms of SD-WAN or any other, so we have the smart accounting concept. So we're going to keep your device noted like what this device belongs to customer X, and we're going to give you a smart account. In this smart account, you as a customer are going to manage which device and what sort of controller profile do you need, right? You can have multiple controller profile, you can have multiple network in order to have PNP, right? You can have, let's say, your company like Gap. Gap has a retail store and CarpNet as well. They can have one smart account, they can have two virtual accounts and two controller profile altogether different, and their devices can talk to their separate overlay in order to have plug and play or ZTP, right? So it's just like having your device information in the plug and play or ZTP server, and in the ZTP, in the virtual account concept, you're going to define your controller profile where you say, okay, these are the devices. If they comes to me, please point out this configuration when I say have this org name or have this vBond. So you're going to do the redirection from the controller profile. The moment you plug in a device with the help of DSCP pointer, it will go and resolve devicehelper.cisco.com, and it reaches out to your PNP server and look at the profile. Based on the profile, it gets the org name or your vBond information and reach out to the vBond, and the vBond connects to the vManage and the vSmart, and the vManage will have a template, push out the template, and bring up the device. And device gets the configuration from the vManage. And then it is done. Yep.
Is that initial communication between the WAN edge device and the PNP server, is that HTTPS, or what's that initial communication look like to the PNP server?
Okay, it's a DNS-based query. Okay. Yeah,
So
just do DNS query, and then it's reach out to the PNP as of today.
Okay.
Yeah. Yeah. So but the one thing is like currently we support just the DSCP, and we don't have auto API capability like what we had in VH, but we are working on similar capability to come up something. Yeah. So in terms of